We propose Text2NeRF, for text-driven 3D scene generation with neural radiance fields. Given an input text prompt, a cozy living room, for example, we first employ a pre-trained text-to-image diffusion model to generate a text-related initial view as the content prior, and employ a monocular depth estimation model on the generated image to infer the geometric prior. We then warp the initial view into a support set, via the depth image-based rendering. The support set containing various views is used as initial training data to initialize the 3D radiation field, NeRF. Afterward, we design a progressive scene inpainting and updating strategy to complete missing regions consistently and update the radiance field to produce visual pleasing and view consistent results. Specifically, we render the radiance field in a novel view K, and obtain the RGBD images with missing regions. We then implement text-driven inpainting by using the diffusion model to complete the missing regions according to the input prompt. For the inpainted image, we also use the depth estimation model to infer its geometric prior. Considering the misalignment between the depth maps estimated in different views, we employ a two-stage depth alignment strategy to align the newly estimated depth map with known depth information. Finally, the inpainted image and its aligned depths are used to construct the support set SK, and further update the 3D radiance field. Again, we rendered the updated radiance field in a novel view K+1, and update the radiance field with the new inpainted results. To evaluate the performance of our method on text-driven 3D scene generation, we compare our method with 7 baseline methods, including 3 existing state-of-the-art text-to-3D methods, ClipMesh, SJC, and Dream Fusion, 1 modified version of Dream Fusion for 3D scene generation, Dream Fusion Scene, 2 novel view synthesis methods from single image, 3DP and Pixel Synth, and 1 recently archive-published concurrent work, Text2Room. Since the ClipMesh, SJC, and Dream Fusion are designed for simple 3D object generation, they fail to generate complex 3D scenes related to the given prompts. In contrast, the modified Dream Fusion Scene successfully generates text-related 3D scenes with more complex geometry. Still, it cannot deduce detailed structures and photorealistic textures for the generated scene since the deep semantic priors provided by the text-image method cannot constrain low-level details. Unlike existing text-to-3D methods guided by the deep semantic priors, novel view synthesis methods, 3DP and Pixel Synth, achieve to produce photorealistic text-related 3D scenes with textual details, since they leverage the low-level content and depth priors to guide the 3D generation. However, since their scene extrapolation is implemented within a limited view range and is independent of the input prompt, they cannot generate semantically consistent content in some novel views of the scene. Compared to novel view synthesis methods, the concurrent work Text2Room and ours leverage the text-conditioned diffusion model as the inpainting module to complete the missing regions of 3D scenes. Unlike Text2Room that uses polygon meshes to represent generated scenes, we adopt NeRF to encode the 3D scenes in an implicit network. With explicit mesh representation, Text2Room fails to generate some outdoor scenes and easily produces stretched geometry in the regions of depth discontinuity. In contrast, our method achieves to generate indoor and outdoor 3D scenes with complex structures and photorealistic details. Here are some more results generated by our method, Text2NeRF. Given different text prompts, our method is able to generate high-fidelity indoor and outdoor 3D scenes with realistic textures. Moreover, our method allows to generate diverse results from the same text prompt, such as, a locomotive at the train station, and, a deserted commercial street. Additionally, our Text2NeRF can also generate 3D scenes in some artistic styles, such as, Venezia in oil painting style, a unicorn in a forest, CG style, and future city and surrealism style. Furthermore, our method is not limited by the view range and can generate 360-degree scenes thanks to our progressive scene inpainting and updating strategy. Thanks for your watching.